Section 7.3.3. Use the accompanying data table to A. Draw a normal probability plot. B. Determine the linear correlation between the observed values and the expected z-scores. C. Determine the critical value in a table of critical values of the correlation coefficient to assess the normality of the data. So we want to draw a normal probability plot. Okay, so here we're given the index of I here. There's the observed value. And there is our expected z-score. So these are the two columns that we're working on. So we want to make sure here that we're going to plot the observed values on the horizontal axis and the corresponding expected z-scores on the vertical axis. So let's go ahead and open this up into StatCrunch. So we're going to click here to view the table. Okay, and then what we're going to do is we're going to open that up. Open it up in StatCrunch. Okay, and so now we have our observed value and our expected value. Now, normally you want to go to the QQ plot. Okay, so those are some of the directions that you're going to see in the textbook. But because we are already given the observed value and expected z-score, we just need to go to the scatter plot. So we're going to go to scatter plot. We're going to make sure that the x variable, again, is our horizontal axis. So we want to make sure that that is the observed value. And we want the y value to be the expected z-score. And so now we can go ahead and then select compute, and therefore there is our graph. So therefore, this represents our normal probability plot. And so what this tells us is that we have, if we draw a line through there, it's pretty close to a linear situation. And so therefore, this is our graph. Okay, now in part B, we want to be able to determine the linear correlation between the observed values and the expected z-scores. So now the next question wants us to determine the linear correlation between the observed values and the expected z-scores. So what we're going to do is we're going to use StatCrunch again. So we're going to go into StatCrunch, okay, and we're going to go to Stat. And we've done this in the past here in the previous examples when we talked about regression. So we're going to go to Regression and then go to Simple Linear. And then the x variable is going to be the observed value, and the y variable is going to be the expected z-score. And now we're going to select Compute. Okay, so we're going to select Compute, and I'm going to copy this part here so we can see what we're looking for. So what we want to be able to determine here is the linear correlation coefficient. So that is that one there. And so we know that R, rounded to 3 decimal places, is 0.976. Now in part C it says determine the critical value in a table of critical values of the correlation coefficient to assess the normality of the data. Okay, so what we're going to do is we first need to determine, okay, what is our sample size? Which is represented by the value of n. So if we come up here, the sample size goes all the way to 8. So the sample size is 8. So we know the sample size is going to be 8. Okay, and then we want to find the critical value, rounding it to 3 decimal places. So in order to find the critical value, what we need to do is we're going to look at the table. So if we come down here and want to look at the sample size of 8, so we can see here that the sample size is 8, has a critical value of 0.906. So therefore, the critical value is 0.906. Now, to assess the normality of the data, we would compare the values of the correlation coefficient and the critical value. If the correlation coefficient is greater than the critical value, then the data are from an approximately normal population. And so by comparing that, we have the linear correlation coefficient R, and then we have the critical value. So if R is greater than the critical value, then the data is coming from an approximately normal population. So we know that R is 0.976, and we know it's greater than the critical value, which is 0.906. So therefore, we can say that the data are from an approximately normal population. Otherwise, if R was less than a critical value, then it would not be coming from an approximately normal population.